admit that some of you were challenged, but equally, some of you got it right. So it's not a situation of nobody could score. Some of you equally had it right. So the question says, a light horizontal beam is 15 meters long and is supported at the left end and at 3 meters from the right end. So it's supported at the left end and then 3 meters at the right end. Please, I hope you can hear me out.
Yes, please.
Okay. So then the beam carries the following loads. So let's first draw the diagram. We are told it is a horizontal beam 15 meters long. So you just draw something to represent the dimension given. Just a representation of the dimension. And I'm assuming this line gives me the 15. So it is supported at 2 ends. Okay, it is supported it's supported at the left end and at 3 meters. So there's a pivot at the ends A, B. And then 3 meters from the right, we have the other supports. So from the end to where the support is, we have a distance of 3 meters. Then the beam carries the following loads: 120 Newton, 2 meters from the left. So we have a load of 120 Newton, 2 meters from the left end. So from A to where this load is 2 meters. 80 Newton, 5 meters from the left hand end. So from this same left hand end, we have another load of magnitude 80. So if it is 80 Newton from the left hand end, then if this is 2, we should have this to be 3. Because from the end to where this load is, we have a total of 5 meters. Then 90 Newton at the right hand. 90 Newton at the right hand. So we have a load of 90 Newton just at the right hand. Make a sketch of the beam and clearly show all its dimensions and loads. This is it. This is what is expected of you. Okay, as in determining the dimension. Please don't forget that the whole load, this whole beam, has a dimension of 15 meters. 15 meters. Please, any question with regards to the diagram on the board? If you are not clear with something, before we continue. So this is the expected diagram which you have to draw. Okay. So a light horizontal beam is 15 meter long and is supported at the left end and at 3 meter from the right hand. So it's supported at the left hand and then 3 meter from the right hand. So this is the right end. 3 meter from there, we have another support. Okay. Then the beam carries the following loads: 120 Newton, which is 2 meter from the left. From the left, we have a load of 120 Newton, which is 2 meter from the end, left hand end. So then 80 Newton, 5 meter from the left hand end. So 5 meter from the left hand, we have another load, which is 80 Newton. So if this is 2, then from 120 Newton load to where this is, we must have extra length of 3. Let me create difference a little bit. So then we have 90 Newton at the right hand end. Okay, what I'm saying is that we are told this is 120 Newton from the left, 2 meter from the left end. So from the left hand end, 2 meter, we have this load. Then we are told that we have another load, 80 Newton, which is 5 meter from the left end. Okay, so it means that when you measure 5 meter from this point, you locate the position of the 80. But already, this is 2. If this is 2, then I must measure extra 3 meter from the 2, where this load is, to locate the dimension of this. Okay. Then the third point is that we have another load, 90 Newton at the right hand end. At the right hand end is the end B. We have a load of 90 Newton acting there. So make a sketch of the beam and clearly show all its dimensions and loads. This is it. Then calculate the reactions of both points of support by taking moments about both supports. So we have to calculate reactional forces at the end, meaning we must determine the reaction force produced by support E. Let me shorten it. So let's assume that is R1. And then the reactional force produced by the support B. Let's assume that is R2. Okay. So we use the principles of movement. One, but then before we do that, if the whole beam is 15 meter length, and then this is 3 meter, what will be the dimension from the 80 Newton to the pivot, to the supports over here? If the whole length is 15, what will be the distance from this pivot or support to the 80 Newton weight? I mean, this distance. What will that be? Yes, can somebody help me out? What will be the dimension?
7 meters.
How did you get that? How did you get 7?
Yes, I added the 2 plus the 3 plus the 3.
Okay,
And I
so
got 8.
5, 8.
Yes, please.
Thank you. So this must be 7 meter. So let's apply the principles of moment. Sum of upward forces must be equal to the sum of downward forces. So R2, R1 plus R2 must be equal to 120 plus 80 plus 90. When you sum this up, you have a total of 290. So this becomes equation 1. Now, whenever you have two pivots problem, you take moment about one of them. You take moment about one of them. The choice is yours. It can be this or that. So let's pick moment about one of them. Taking moment about support A, B. So taking moment about B, I'm choosing B. And whenever you take moment about one of the supports, the other support is eliminated for now. But it doesn't go with the reaction. The reaction still survives. The reaction, Millicent, are you there? The reaction still survives. Okay, so let's take, you identify clockwise movements and then anti-clockwise movements. Because we are taking moments about B, okay, this will give us clockwise, anti-clockwise. This will also give us anti-clockwise. This will give us clockwise. This will also give us clockwise. And R2 would give us zero reaction. Zero turning effect because it has no perpendicular distance. Okay. So I'm coming in. All right. So let's determine sum of clockwise movements. The sum of clockwise movements, we have R1 times 5 plus 7, which is 12, plus, this is also giving us clockwise movement, 90 times 3. So we have 12 R1 plus 270 for sum of clockwise movements. Then let's look for the sum of anti-clockwise movement. Anti-clockwise movement. Here we have 120 Newton, 120 times the perpendicular distance from B, 3 plus 7, which is 10, plus 80 by 7. So 1200 plus, what is 7 by 8? 7 multiplied by 8.
56.
56. So you determine the complete value 12,200 plus 560, and we have 1,760. This is equal to 1,760. Then for equilibrium, sum of clockwise moments must be equal to the sum of anti-clockwise moments. So you equate the two. Summation of clockwise moments. I don't want to write a lot. The reason for which I'm shortening must be equal to summation of anti-clockwise moments. What is the sum of clockwise moments? 12R1 plus 270 is equal to 1,760. Then you determine R1. What is 1,760 minus 270? Get that for me. 1,760 minus 270. Hello. Oh. Who is telling?
1,490.
Let's hurry up, please, with our responses. So divided by 12. Divide that by 12 for me.
$124.167.
124.167. Okay, let's make 17 Newton. That's the reaction at the first support E. Now, I will not encourage you to use this. After determining one of them, I wouldn't encourage you to use R1 plus R2 to be equal to 290 to find R2. The reason is that you will never see anything wrong with your answer if you use this. Or supposing you get R1 wrong. When you use this, you will not see that R1 is wrong. Because you are equating the upward forces to 290, certainly because you have one of them, you get the other. But you won't be able to identify that your answer is either correct or wrong. Okay, so the best thing is that take the movement around the other supports. Then use your answers to test this, that if R1 and R2 is equal to 290, then your answers are correct. If not, then it means your answers are wrong. But you see, because I have R1, R2 certainly would be equal to 290 minus R1, and it will give me an answer. This is correct only when R1 is also correct. But in case you had R1 wrong, you wouldn't know. But if you go through the other process, determine R2, then you use this as a check of your answer. If R1 and R2 gives you 290, then you are so sure that your answers are Correct. Please, do you understand what I'm trying to tell you? Do you understand it?
Yes, please.
Yes.
So let's notice whatever we have for R1. 124.17 Newton. Then take the moment around the other supports. Then we use the first principle as a check of our answer. So we bring the other supports back. Then this time, because we are going to take moment around A, we clear this. But the question is that it doesn't go with the reaction. It doesn't go, or it's not eliminated with the reaction. Now we identify the moment. Now, this will give us 0 moment. R1 would give us 0 moment, but the direction of this ones will also change. This time, 120 would give us clockwise, 80 clockwise, 90 clockwise, and then R2 gives us anti-clockwise. Turning effect of R1 is 0. So taking moment around A, sum of clockwise movement we have 120 by 2 plus 80 by 5 plus 90 by 15. Then anti-clockwise movement, we have R2 by 12. Then we equate. So let's sum this up. Please determine the sum of clockwise movement for me. The sum of clockwise movement.
1990.
1,990. Okay. So summation clockwise movement is equal to summation of anti-clockwise movement. So 12 R2 is equal to 1,990. Therefore, R2 would be equal to over 12. And what is 1,990 divided by 12?
Ours is 5.83.
So 165.83 Newton. So we haven't had this. You then use the first principle to check your answers, that R1 plus R2 must be equal to 290. Sum of upward forces must balance the sum of downward forces. Okay, so put in your values. 124.17 plus 165.83. What is the result? When you add this to, what's the result? Approximately equal to 290. Then you can be confident that your answers are correct. But you see, so when you obtain one of them and you use equation 1 or the principle 1, you can only get it if your answer is correct. You can only get it if your answer is correct. If your answer is not correct, you may think you've had an answer. Meanwhile, it is not correct. That is the issue I'm talking about. Please, any question? Is there any question? All right. If there is no question, I have a moment question on Nigeria 2024 physics. They have taken their WASI. And there is a question which dropped under moment. Let's quickly go through it. So I'm reading. A uniform stick AB, please write it for me. A uniform stick AB of length L and mass M. The length is capital L. The mass is small m. A uniform stick AB of length capital L and mass small m is balanced horizontally. On a knife edge which is 10.0 centimeter from A. A is capital. A uniform stick AB of length capital L and mass small m is balanced horizontally on a knife edge 10.0 centimeter from A when an object of mass 400 gram, is suspended at A. When an object of mass 400 gram is suspended at A. When the knife edge is moved, 5 centimeters further, when the knife edge is moved 5 centimeters further, the object has to be moved to a point 9.0 centimeter from A. When the knife edge is moved 5 centimeters further, the object has to be moved to a point 9.0 centimeter from A for the stick to balance. 1. Represent the balance system with a suitable diagram. Represent the balance system with a suitable diagram. II. Determine the mass of the stick. II. Determine the mass of the stick. And III. Determine the length L. III. Determine the length L. Let me quickly go through the question again. A uniform stick AB of length capital L and mass small m is balanced horizontally on a knife edge 10.0 centimeter from A when an object of mass 400 grams is suspended at A. When the knife edge is moved 5 centimeters further, the object has to be moved to a point 9.00 centimeter from A for the stick to balance.
Please, I didn't hear that part.
When the knife edge is moved 5 centimeters further, the object has to be moved to a point 9.00 centimeter from A for the stick to balance. So, Baba, don't worry. I'll drop it in the group. I represent the balance system. Represent the balance system with a suitable diagram. Then determine the mass M of the stick. Then determine the length L of the stick. So I'm going to take a quick shot and drop it, okay, in the group. What I want you to do is that first you have to draw. You have to draw. Then we go through after your diagram. Okay, so it's been sent to the group. You have to zoom it to see it clearly, okay? So within 5 minutes, you would have to think through and draw. Okay? Produce the drawing for me whilst I take a shot of attendance and drop it into the group. Then I'll get back to you. So start with within 5 minutes. So a uniform stick AB of length L and mass small m. So this beam is uniform. or stick. We are told it's a stick. If it's uniform, this is its length L. It is uniform, meaning that if it's uniform, then its total weight or mass acts at the midpoint or the center. So its mass must act at the midpoint So this is the point where the mass actually acts. Small m. We're told the mass is small m. It's being uniform also means that from the ends, we have half of this length. Okay, so the dimension of this mass from the end is half of the whole. Okay, so this is the first part of the information. So a uniform stick AB of length L and mass M is balanced horizontally on the ninth edge 10 centimeters from A. So from A, this is A. B, we have a ninth edge which is 10 centimeters from A. And so there's a ninth edge or supports. This support is 10 centimeters from the end A, so 10 centimeters. 10 centimeters from A, when an object of mass 400 grams is suspended at A. So we have an object of mass 400 grams suspended at A. Now, when the knife edge is moved 5 centimeters further, the object has to be moved to a point 9 centimeters from A. So when we move the knife edge, another diagram. Because we are changing the first condition from the second condition. The reason for which we need another diagram. It is the same state, uniform state. So its mass is here. Meaning the same dimension is what we have. So half of L. The only change is that when the knife edge is moved 5 centimeters further, before it was 10 centimeters from A. Now it is moved 5 centimeters further, meaning that from the end to where the knife edge is, this time we have 15 centimeters. Because it is moved 5 centimeters further. When the knife edge is moved 5 centimeters, the object has to be moved to a 9 centimeters from A for the stick to balance. Before, the object was just at the end. But when we move the pivot 5 centimeters further, the object has to be, its position has to be on the 9 centimeters from A for the stick to balance. So the same object, 400 grams, has to be moved in, and the distance from the end A to its new position is 9.009 centimeters. Don't forget, before it was just at the end of A. From A. Now represent the balance system with a suitable diagram. So that's exactly what we've done here. Okay. Then determine the mass M of the stick. So this must be the diagram. Now, because we are dealing with two different situations, we'll have two equations to deal with. Okay, so first one, this will give us anti-clockwise moment. This will also give us clockwise moment. But the point is that if from the end to where its weight or its mass is L, and this is 10 centimeters, what will be the distance from the pivot to its center of mass? What will be this distance? Yes. Help me out. If this distance, the whole distance is L, half L, and this is 10 centimeters from the pivot, what will be this perpendicular distance of N to the pivot?
Please.
Yeah.
Please, half of L minus 10.
So this is half of L minus 10. Thank you. So 0.5 L minus 10. What about this distance? What about this distance? This is still half of L.
Half of L minus 15.
Thank you. So 0.5 L minus 15. So please, let's determine equation 2. Sum of clockwise being equal to the sum of anti-clockwise moments. Clockwise moment must be M times the perpendicular distance, 0.5 L minus 10. Then anti-clockwise moment, 400 times 10. This is equation 1. Then in the second situation, this is still anti-clockwise, this is clockwise. We have M times the perpendicular distance, 0.5 L minus 15 being equal to the anti-clockwise moment. Now, what is the perpendicular distance of this from the pivot? What will be the perpendicular distance? Hello, what's
Centimeters.
pardon?
6 centimeters.
Good. So if from the end to this is 15 and this is 9, then the deficit must be 6. So 400 times 6 will be the anti-clockwise moment. And this is equation 2. I want you, so when you divide equation 1 by 2, okay, when you divide, you have 0.5 L minus 10 over 0.5 L minus 15 being equal to 10 on 6. Because 400 will also cancel out. Okay, quickly go through this. Help me determine the value of L. When you have determined L, we can find M. Start work. Start work. Do it for me. Everybody, please get involved for me. All-inclusive thing. Okay, so what have we had for L? The value of L. Anybody to share that with us? Okay, Caleb.
Sir, please, I had L to be 45.
Come again.
I had L to be 45.
Okay, let's confirm. All right, so when you cross multiply, you have 10 on 0.5 L minus 15, which is equal to 6 by 0.5 L minus 10. So 5, when we divide 2 by 2, 5 by 0.5 L minus 5 by 15 is equal to, we are dividing 2 by 2. So this would also be 3. 3 by 0.5 L minus 3 by 10. Okay. So this is 2.5. 5 on 10. So 2.5 L minus 75 is equal to, this is also 1.5 L minus 30. So that when you group like terms, you have 2.5 L minus 1.5 L being equal to 75 minus 30. This is giving us L 2.5 minus 1.5. So L is equal to 45 centimeters. So how many of you got L to be 45? Do we have a lot of you getting that? Okay. Okay. Then what about M? What about M? Erifa, what did you get for M?
Please, I have a question.
Okay, go ahead.
Mr. Edia, please, can you explain why we were dividing?
Oh, I just wanted to reduce the values down. Because when I
No,
multiply,
before that, where,
why
yes,
I
that part.
divided equation 1 by 2.
Yes, please.
Oh, I have 2 equations to solve simultaneously. So the way a manner will go by it is what I did. Okay. So
Yes.
you could have also chosen a different way. Maybe make one of the variables the subject, substitute it in the other or something like that. Okay.
Yes.
All right. So what have we had for M? Della, Eva, Khaled, Kelvin, Leslie, what have you had for M? Julian, Rachel, and all the names. Eva, no one is talking. I have 31 of you and everybody is quiet. What did you get for M? Hey, no one. You. Okay, then let's quickly go through. If no one is talking, let's quickly go through. Okay, so substitute L into one of the equations. Pick any of these equations and substitute your value of M into it. So M 0.5 by 45 0.5 by 45 minus 10 is equal to 4,000. If 4,000, then what is 0.5 by 45?
22.5.
22.5 minus 10.
12.5.
Is equal to 4,000. Divide 4,000 by 12.5. And that should give you
320.
exactly. And you were quiet. That's important. 320 grams. So here, whether you use equation 1 or equation 2, you have the same result. I want you to test the same thing by substituting L into equation 2. So use equation 2, substitute L, and let's see what that would also give you. I'm waiting for you, so hurry up. Della, Elizabeth, Eva, Baxen, Hilda, Gabby, Julian, you are all here and you are not answering my question. How could you? Della,
This is the same thing.
Don't disturb me. Okay, so you get the same answer. Gabby, your hand is up. Is it about the
Yes,
same
please,
thing?
I got the same answer.
Exactly. Okay, so this is Nigerian WASI 2024 question or moment. And I think answer this and then earn a total of 6 marks. That's simple. So please, moment of a force is not difficult. And moment, this is the only part you'll be taking through some theories such as stable, equilibrium, neutral, unstable equilibrium. Those are theoretical things, but the calculation part is this. And you will be doing this in practicals as well. But practicals is just theoretical. For practicals, when you understand your theory, okay, you can even use the theory to get your values without doing the practical thing in the lab. So this is the nitty-gritties of moment of a force. not so difficult. Please, if you have any question, quickly ask. If you don't have any, we move on. So, do I have anything? Please, those of you, okay, Arifa.
Please, I wanted to ask that. Does it mean that when solving moment, please, does it mean that when solving moment, immediately you change the pivot that you are solving for, the force's direction will change
The force's position,
from the first?
the moment you change the pivot position, the position of the masses or the forces around must also change so that you can obtain a balance, else it will not balance.
Yes, please, but
Go ahead.
I also want to ask for the first question. You see, the first one that we saw before this one, we had like two different pivots, and then the 120 Newton was going anti-clockwise. But when we changed the pivot, it went clockwise. So does it mean that immediately you change the pivot, the direction can change?
Yes, the direction is the turning. As you look at my hand, we have a balanced situation. Okay, the moment you change the pivot, the turning will change. So
Okay.
in the earlier situation, we had two pivots, one here and one there. Okay, the moment you take turning effect around any, it will change. So if I'm taking it around this one, then I'm going to ignore this. Is that okay? So
Yes.
it will change. The direction will change whenever you change the position of the pivot.
Okay. Yes, please. Thank you.
All right. Please, is there any other question? All right. So this is it about moment of a force. So please, those of you who had issues with moment, just after today, okay, go through the examples we've solved. And I think these examples are a little bit challenging so that when you manage to understand, you can easily apply it to all other questions. If you have a question or you try solving a problem and you are not able to, you can forward it to me to look at it for you. All right, so we are beginning a new topic, light or optics. Light. Light is very broad. And I'm hoping we can go through light. Every aspect of it before. Let's remute yourself. Light. You did, I'm sure you went through some aspect of light in JHS. Rectilinear propagation of light. I think you also looked at the pinhole camera. The pinhole camera, which also applies the principle of light. So class, what is light? Share with me what light is. Anybody to tell us what light is? Anybody? 32 of you. Okay. Is it Elizabeth? Elizabeth, go ahead.
Yes, please. Light is the energy that makes objects visible.
Okay, so the energy that makes objects visible. More light. Give me more light or throw more light on light. Who else? Who else will share something on light? Okay, Caleb.
Sir, please. Light is a form of energy that travels in a straight line and aids in vision.
Okay, that's also good. Any other clarification or view on what light is? Okay, another hand. Go ahead, please.
Light is the energy that stimulates vision and also helps plants to prepare food and provides them with energy.
Okay. In fact, wonderful. All these views actually talks about light. This is how I also talk about light, or my perspective of what light is. I'll also say that what you said by the three contributors, perfect. But I'm adding on. I'll also say that when we talk about light, light is that part of the electromagnetic spectrum. Light is a part of the electromagnetic spectrum that stimulates vision or enables us to see. Okay. Now, I said electromagnetic spectrum. Spectrum. What do we mean by electromagnetic spectrum? We have some waves which we classify based on their common features or properties. We put them under one umbrella, and this umbrella is what we are referring to as the electromagnetic spectrum. So we have what we call as electromagnetic waves, EM waves. When we talk about electromagnetic waves, they are waves that can easily be propagated without any material medium. Okay, waves that can easily be propagated without any material medium. When we talk about waves, in fact, we are actually in an ocean of waves, meaning we have waves all around us, because we apply waves in so many ways. Example, you pick your mobile phone, your laptop, as I'm communicating with you. You pick your mobile phone. When you want to talk to somebody, you just dial the number. There is no wire connecting your phone, but with something which is that invisible thing, you could dial and then reach whoever you want to talk to, and you'll be communicating. It implies that something links the phone. That is a wave. You tune in the operation of the television. You tune into a station, television station. You tune into a radio station, and you could hear something, meaning something elsewhere could connect your radio and TV, waves, DSTV. Mention them. We pick waves from the sun, travel from that distance, and then reach us. We don't see whatever is being produced by the sun, but we could feel waves. The reason for which I said we are surrounded, or we are in an ocean of waves. Okay, so when we talk about electromagnetic waves and the classification of waves, we have two main parts. We have what we call mechanical waves and electromagnetic waves. For mechanical waves, before they can be propagated or transmitted from one point to another point, there must be a medium. Meaning, for mechanical waves, if there is no medium, they cannot be transported or propagated. A typical example of a mechanical wave is sound wave. When I speak, before you could hear, there must be air. If there is no air, sound cannot travel. So sound waves require a medium for propagation. Another example of mechanical wave is ocean wave. The waves you see on the surface of the ocean, there must be water. If there's no water, there cannot be ocean wave. So all waves that will require a medium before they are propagated from one point to another are mechanical waves. There are some other waves that do not require a medium. Whether there is a medium, they can be sent. Whether there is no medium, they can still be propagated. Okay? An example, all these waves that do not require a medium for propagation are what we are terming as electromagnetic waves. So electromagnetic waves do not require any material medium before they are propagated. And examples, we have gamma ray. We have X-ray. We have UV, ultraviolet. We have visible light. Visible light. We have infrared. Infrared. We have microwaves. We have TV signals. Radio waves, TV signals, so all these waves do not require a medium, and the reason for which we classify them as electromagnetic waves, they are actually produced as a result of electric field and magnetic field. The reason for which we are describing them as electromagnetic. Their nature is basically of electric field and then magnetic field. So apart from they not requiring any medium for propagation, they also have another feature. The other feature is that all electromagnetic waves travel with a speed. They have a common speed. They can travel at a speed of 3.0 times 10 to the power 8 meter per second. So all electromagnetic waves travel at this speed, meaning within 1 second, they could travel a distance of 300 million meters. What a wow! Per second. All EM waves could travel a distance of 300 million meters within a second. So this is what we mean by electromagnetic waves. Then the spectrum, electromagnetic spectrum. we arrange. These waves are arranged in order of increasing or decreasing wavelength and frequency. So we group them among these lots. Which one has the shortest wavelength? Gamma ray, followed by X-ray, followed by UV, visible light, infrared. So they are arranged on a table based on their wavelength and frequency. Arrangement of these waves based on these features, their wavelength and frequency on a table is what we are describing as the electromagnetic spectrum. Broad waves of some features. Okay. So the visible light which we are talking about is part of the electromagnetic spectrum. Okay. The reason for which light is said to be part of the electromagnetic spectrum that stimulates or aids vision. Any question? Importance of light. Importance of light. During your views about light, you gave me some importance. Can we revisit them? What are some of the importance of visible lights? Yes. Importance of visible light. Oh, Caleb. Okay, revoir.
Please, it aids in vision.
So it aids viewing or vision or stimulates.
Sir, please, the question again.
Oh, the question is about importance of light. How is light important to us? Caleb.
Sir, please, it aids plants in photosynthesis.
Okay, so it also aids plants to prepare their food, which is the process of photosynthesis. Do we have any? Nanadwa?
It aids in telecommunication.
How? Nanadwa? How does light aid telecommunication? Can you explain?
No, please.
Yo, okay.
Sir, please, can I come in for it?
Come in.
Sir, please, during how light aids in telecommunication is due to this. Since telecommunication makes use of electromagnetic waves, any amount of light which is not enough or more than the waves of the telecommunication uses would disrupt in its use. For example, during solar flares or when we experience weather conditions, we notice that our networks seem to drop or seem to slow down.
You see, the telecoms use microwave, one of the waves and the electromagnetic waves for distance communication, this one. Okay, so microwave, that wave is used for distance communication. Now, with regards to what you are saying about it aids in telecommunication, I was expecting to hear something on fiber optics. Okay, fiber optic communication is the use of the wave or information to be transported is bundled into light, the form of light, and channeled through special material, fiber cable. So I was yearning to hear that part being said. Is that okay? But telecoms use one of them, microwaves, for distance communication. All right. Now, apart from 8 vision helps plants to photosynthesize, light from the sun, okay, light from the sun also provides us with heat. Anyway, the sun provides dual purposes, provides light and heat, energy. Okay, and they come, the two energies come in the form of a bundle. Once the sun produces visible light as well as heat energy. All right, let's look at sources of light. But before we look at sources of light, can somebody tell me how we manage, how do we see? What is the science of seeing? Before you can see your brother, your sister, your parents, what is the science behind it? So the question is that, how do we see? How do we see? Yes, Caleb. Caleb, how do you see?
Sir, please. We all know that light has the ability to reflect, which is a bounce of surfaces. So when light rays tend to hit a particular surface, let's say hit a book, the book absorbs. Light is made up of 7 different colors in a spectrum. So the book, let's say, has a color of green. It absorbs all the colors in the lights that are not in the light spectrum that are not green, and then bounces back the green light towards our eyes, so that we would be able to see the green light. Same happens with other objects. When it's white.
Caleb, can you explain to me how the process involved before you see your brother?
Sir, please, first, the light rays are cast on him. They travel in a line, a straight line, which is direct linear propagation. So when a light ray strikes him, reflection occurs, which is they bounce off of him. So he is the surface now. And then the light rays reach our eyes, which we are able to see.
Okay, so what is this source of light which reflects from your brother?
As in the light source.
Yes, which reflects from your brother. Okay, thank you. In fact, that's perfect. So basically, we see as a result of reflection. Okay, before you can see anything, there must be a source of light which illuminates the object you want to see. So you see, even in the day, this morning, should we enter into eclipse, we can't see. We can't see because the sunlight is what produces the beam or rays. So the light from the sun incidents on objects around. Then the object also reflects the incidental light from the source, here the sun. Okay, so the reflected energy from the objects or the rays from the objects is picked by the eyes, okay, and then goes through interpretation. Okay, that's it. So we see as a result of reflection. The reason for which when you are in a dark environment or dark room, you cannot see anything. You can't see anything because there is no source of light which is incidenting on objects within the room and then reflecting into your eyes to for interpretation. So basically, we see as a result of reflection. Okay, please, any question? No question. Now let's talk about sources of light. Sources of light. Lenny, give me one of the sources of light. From which sources do we get light?
The sun.
Lenny, I'm listening.
Say please, the sun.
The sun is one, so we could get light from the sun too. More sources. Let me call some people. Some people do not talk. Hilda, give us one of the sources of light. Hilda.
A glowworm.
Pardon?
A glowworm.
Glowworm. Hilda, have you seen a glowworm before?
No, please.
Okay. All right. Let's talk about sources we know of, then we look at what we don't know. Adam, your hand was raised.
The firefly.
Pardon?
Firefly.
Fireflies. Adam, have you seen a firefly before?
Yes, sir.
Okay, as for fireflies, they are common. More views. More views of sources. Okay. Yes, Elizabeth.
Please, fire.
Fire. So burning firewood. You can't just write firewood. Burning firewood, charcoal, coal, and all burning stuffs. Savo. Lighted torch. Lighted torch. The point is that, you see, the same torchlight, if you don't own it, okay, basically torchlight, because here you are referring to the light. So torchlight. But you can't indicate torch. Okay. Burning candle. Burning candle. So do we have some other examples of sources? We can talk about the moon, stars, and even mirror. Sun, glowworm, firefly, some sea fishes, even some sea fishes. Let's qualify it. Some sea fishes, like electric fish. Okay, deep sea creatures would also Yes. Either the same as some sea fishes. All right. And so many other examples. However, you see the sources of light, we can group them into two: luminous bodies and non-luminous bodies. These sources of light, we can put them under these two umbrellas: luminous bodies and non-luminous bodies. When we talk about luminous bodies, these are bodies that produce their own source of light. And the sun is an example of luminous bodies. So these bodies produce their own source of light. The sun is one. We can also put in firefly, glowworm, then the sea fishes or ocean creatures, some ocean, okay, burning firewood, charcoal, candle, okay, and etc. Then we have non-luminous bodies. For non-luminous bodies, they do not produce their own source of light, but they always reflect light from a source. An example is the moon, then mirror. These bodies do not provide their own source, but they reflect light to look as if light is coming from them. Okay. Under the same grouping, we can also group these sources under another two umbrellas, which is incandescent and fluorescent sources. When we talk about incandescent sources of light, we are talking about all sources of light, all sources that produce light when heated. So they can only produce light for incandescent sources. They can only produce light when heated to a higher temperature. Okay. An example of incandescent sources, we can refer to the sun as an incandescent source. Burning firewood, charcoal, candle, they all provide or produce light when heated. Then we also have incandescent bulbs. These days, they are not common. Charcoal, candle, some bulbs, incandescent bulbs, and so on and so forth. Then we have fluorescent sources. These ones do not produce light when heated. And so, under this classification, we can talk about firefly, some sea creatures or fishes, torchlights. Okay, so sources that even fluorescent tubes or bulbs also come under this category. Basically, all that we are looking at, sources of light or sources that produce or could produce light when their temperature is very, very minimal. So these are classifications of light and examples. Please, any question? Any question? All right. Now let's look at properties of light. Let's discuss properties of light. These are just the beginning, okay, stuffs about light. Properties of light. Light can exhibit a lot of properties or characteristics. What are some of the properties or characteristics of light? Yes. Okay, Gabby.
Please, light travels in a straight line.
Okay. Rectilinear propagation of light. Light travels in a straight line. Okay. So apart from the ability of light to travel in a straight line, what other property, Henry? Henry.
It can be refracted.
Okay. So light can also be reflected. It can undergo reflection. So light can be reflected. 3. Light can also be refracted. Can undergo or can go through refraction. Light can also be diffracted. Diffraction. Light can also go through interference. Interference. 6. It can also go through polarization. It can also be polarized. So these are some of there are more, but these are the key properties or characteristics of light. Light travels in a straight line, can undergo reflection, can go through refraction, can go through diffraction, can also go through interference, and can also be polarized. Under this topic of light, we have to go through just a few. We'll go through interference of light. We'll go through reflection. We'll go through reflection of light. Then we'll go through refraction. Okay, under this concept, we will look at reflection, refraction. As for diffraction and interference, and physics, we'll go through it under waves. Don't forget, light is under waves. So when we get to wave motion, then we look at interference and then diffraction, even on the surface, not into details. So, under what we are looking or studying currently, we'll look at reflection of light. What is reflection of light? And what are the conditions that must prevail for light to be reflected? Eva, what is reflection of light? Mami, are you also here and have decided to be quiet? Eva, I've called you. What is reflection of light? Or Eva is gone. Eva, you are here. Okay, whoever is ready should share that with us. Okay, Gabby. Eva, go ahead. If you want to speak, go ahead. If you want to give the chance to Gabby, take over. Please, let's hurry up. Gabby, take over.
Okay, sir. Please, reflection of light is a phenomenon that occurs when a light beam strikes any polished or smooth surface and bounces back to our eyes.
Okay, so Gabby, in summary, what is reflection of light?
It's when a light beam bounces off a surface.
Okay, so the bouncing of light from a surface is what we are terming as reflection. The bouncing of light or the bouncing back of light from a surface is what we are describing as reflection. Okay, so what are the conditions that must prevail for reflection to occur? Conditions for reflection of light to occur. One, conditions that must prevail for reflection of light to occur. Jojo, Ayo. Okay, Julian, take over. Julian.
Yes, sir.
Let me hear from you.
Sir, please. We need a smooth surface.
So Jojo, how Mr. Jojo, Julian, how would you put that? How would you state that so well?
In order for reflection to occur, light has to bounce off a smooth surface.
So we'll put this as the nature of the surface. The nature of the surface. Surface of interference of light. All that we are saying is that if the surface is so smooth, reflection will be greater, okay, at a greater percentage. If the surface is rough, reflection would occur, but the extent of reflection wouldn't be anything that we can see and appreciate. So, in actual fact, reflection even occurs on our bodies. That is why I said we see as a result of reflection. Light from the sun incident on our clothes, our bodies, our shoes, and then reflects. But then, this reflection, okay, from the bodies depends on the nature. If the body is very, very smooth, the extent of reflection will be regular or in an orderly form. If the surface is rough, it will be scattered. Okay, so the nature of the surface, okay, determines the extent of or the nature of reflection. What again? Apart from the nature of the surface, what other condition must prevail for reflection to occur? Then lastly, the nature of the material. Nature of material. Here, what we mean by nature of material is a reflecting surface solid, is it liquid, or is it gaseous? So the nature of the material also informs the extent to which reflection would occur. If the material is solid, how reflection will occur will be different from if the material is liquid and gaseous. So these are the two main conditions that must be in place for reflection of light to occur. The nature of the material and then the nature of the surface of the material. Please, is there any other addition, question? Because it is 8:55. So we can call it a day. If you have any question, ask. If you have anything to add, quickly do so. If there is nothing, then this is where we draw the curtains on today's meeting. Thanks for your time. Thanks for your participation, contribution, and everything. Please, if you have personal questions on what we've done, you can forward it to me for clarification. Okay. All right. So, in fact, take care of yourselves. We'll have another session on Friday. May the Lord be with you. Take care. And in fact, do not forget to learn. Bye-bye.
Bye.
Bye.
Bye-bye.
Bye.
Okay. See you all. Yeah, as usual, your assignments will be sent on the platform.